you have to maintain them as well. So if you don't do that, that's kind of an issue in the long-term perspective. And finally, we decided that incremental boxes are not really an option for us, and we start from scratch whenever we build a new version of the software we run on a daily basis. And it allows us to catch bugs pretty quickly, so we never do like a clean deployment in production. We always do incremental deployment. So when we have like 1.0 version on prod, then we do another deployment, then we deploy 1.1 over that 1.0. In Vagrant, or in Packer actually, we always start from scratch and we deploy 1.1 directly on base box. So that deployment used to behave quite in a slightly different way. So if you deploy stuff incrementally, there is a silent assumption that some stuff is already there when you start from the very basic box, from scratch basically. It used to behave slightly different. And in our case, it works kind of great. Alright, so we have a box, we exported that, we have to distribute that somehow. There are basically three options. HashiCorp has a service called Atlas. Previously it was Vagrant file, so you can use that. You can build your internal one. It's pretty simple, just Google that. So we have that in place, actually. And there are also some third-party services, like Artifactory. So that's a third option. So after all the changes, we have a Vagrant file that the only difference actually compared to the previous one is the fact that we have a custom box here. So instead of that base CentOS box, we have a custom pre-provision box that contains all the services. Right, so final product should behave like this. So whenever you Vagrant up, it should provide you a complete environment. It shouldn't enforce on you any Vagrant provision after that. So after Vagrant app, you should be ready to go. That's assumption in our case. And you have all the services in place. Since after 5 minutes or 3 minutes when the box is imported into VirtualBox, you can start work. Right, so that was the building part, and the third part of the process is ongoing work with Vagrant machines. We have a couple of challenges here. So first is that we assume that none of the procedures you used to follow on a daily basis, so all your habits, like the developer habits, stays as it was before Vagrant. So in our case, when we do a maven click install, for example, it should behave exactly the same when you deploy against Vagrant or a locally running service. So we have a lot of port forwarding rules to actually have faith that we run stuff on localhost. That's not true, but it feels this way. And moreover, we do a lot of Java, so we have settings XMLs, POMs XMLs, and things like that. So these files should also stay untouched. Finally, the environment feel exactly the same as you interact with production. This is what I already said. It should be easy to upgrade as well. When it comes to upgrading, we have pretty much only one way to do that, and it looks like this. So it's git pull burps update Vagrant provision. Git pull pulls all the data from Git repository. Burps update executes good upgrade. So all the new dependencies will be downloaded, and Vagrant provision is run chef inside that VM. But the problem was, for some people, that procedure was like this, but the vast majority of the team actually sees that as exactly this. So the overall feeling was that Vagrant is kind of powerful, but it's slow and heavy. So the expectation was like this. So we need something that's fast, not like featureful, but it should be fast. That's like the primary or the most expected behavior from things like that. It should be fast. So we've been wondering what we can do about that. And thankfully, there's a tool called break in Ruby, which is like makefile, or like slightly like Maven, but for Ruby. So it will do exactly, it will like automate the repetitive procedures, like if you do like Maven clean install and Maven whatever, you can execute like break something and do these two things for you. Alright, so the overall goal was to reduce the complexity of the CLI. So no longer that git pull Vagrant provision or patch update Vagrant provision. We should eliminate the confusion related to bird shelf or the birds command. As for some people, it was kind of unclear when should I actually execute that birds update. And it was really frustrating when you like change the single configuration file and you have to wait like for like 15 minutes to complete, as the flow is like nothing has changed, nothing has changed, nothing has changed. Oh, there's a template I need to render. Render that template and schedule a service restore. And it was like, again, nothing. Alright, so nothing has changed, nothing has changed. Oh, I need to restart the service. And 15 minutes later, you've changed a single file. So that was kind of frustrating. And finally, the final output was like this. 8 out of something resources have changed in like 4 minutes. That's kind of too long for us, so we need to change that to make it much faster. So, we decided to introduce a few changes in Vagrant. First is that we, instead of setting directly a run list, we read a file here from this, which is called .run list, and we use a predefined structure to define a couple of set of chef recipes. So, for example, if we deploy HTTPD, we need to run exactly this recipe, and we basically set read a string from a single file and use that string as a key, that hash. So the chef run list is recipe project HTTPD :: default. And when we do that, we remove the file afterwards, as it is no longer needed. The reason we go for that is the fact that Vagrant file is nothing more than a Ruby file. You can embed pure Ruby in Vagrant file, so that's kind of nice. So that was the first change. The second change is that we introduced a rake file. I know it's small, but I hope you can see that. So we have 3 namespaces here. I'm not gonna like introduce rake here, but hopefully you will get the point what's behind it. So we have like a couple of services here, which is like a HTTPD and a description of that. We have a first namespace, which is bird shelf. And the reason we have it here is to eliminate that confusion about bird shelf. So we have like a procedure that allows us to go from birds file to birds file lock. So whenever you do like birds install, birds update, the birds file lock is generated to basically fix all the or actually save all the versions that you actually downloaded. So we have like a specified all the versions, like you have a 1.1.7 version of HTTPD in your birds file, and when you download that, for example from Git, in birds file log, the same version is saved alongside with like a checksum or a comic number or whatever. So we, to go through that transition from birds file to birds file log, you have to execute birds update or birds install. When you don't have birds file.log, you need to execute birds install, otherwise you have to do birds update. And the last thing here is when the process is complete, we do Berg's vendor, which basically exports all the cookbook to a separate directory, and that directory is like a directory you can upload directly to some server. Alright. Second namespace here is Vagrant. We have just two elements here. It's actually, in practice, it's more, but I have to reduce the amount of code on a single slide. So we have Vagrant app, which runs Vagrant app, and Vagrant provision that runs Vagrant provision. The only interesting point here is that there's dependency. So whenever you run Vagrant provision, the Berg's file log needs to be verified if it is in place. And nice thing about that file thingy here is that when you run Berg's file, so it basically checks the timestamps or the modification times of all these files. So if the Berg file's log is older than Berg's file, then the procedure won't be executed, otherwise it will. So whenever the new change comes from Git repository, the timestamp of the Berg's file changes, and it is newer than Berg's file log, so you have to execute Berg's update or Berg's install to regenerate or actually to fetch all the dependencies. And finally, the most important part here is provision namespace. And we run a very simple thing here. So we open the file called the run list, and we save that key from here to that file, and we follow that by a Vagrant provision. That was the first part of rake file. There's a second part as well, and the second part looks like this. We have a rake init. So init is all about first start of the project. So previously we have like a readme file that you need to follow to like install all the plugins, install all the files you need. These days, all you have to do is like rake init, and all those things will be downloaded. The second thing here is we have a clean procedure. So whenever we release a new version of the box, these boxes will be stored on your local disk in the Vagrant cache. And when you download the new version of the box, you probably don't need all the older versions. So with rake clean, you can get rid of them with just one command. And finally, we have like a top level namespace, which provides us Vagrant app, Vagrant provision, and Vagrant refresh. So after all these changes, the reward was like this. This is how I looked like when I implemented that, and this is how it looks in practice. So we do not run the Vagrant, we do not run Berg shell anymore. We completely rely on rake, which is like a top level wrapper on top of these tools. There's the write -t command, which prints all the available actions you can use. And right now, you don't have to provision all the services, despite the fact you're waiting for a single Apache change. You can do rake provision HTTPD, and that new configuration will be downloaded from Git, and it takes like 11 seconds instead of 15 minutes, which is like an order of magnitude change. So that's kind of nice. It's actually slightly longer than 11 seconds. It's like 15 seconds as the Vagrant provision needs to be kicked in. So that 11 seconds is like the chevron itself. There's like 4 seconds more to run the whole procedure. All right, we have a couple of issues on Vagrant. So the first thing is that we run service discovery tool called Console on our production systems, and we also would like to have that on Vagrant as well. But some of you may wonder, why do I need service discovery on Vagrant where there's just a single machine, so everything is in localhost? What's the point of having service discovery there? And actually there's a lot of point, as we use like DNS interface of Console. So instead of like connect to 192.168.7.14 port 8080, we use like tomcat.service.console 8080. So we don't really care where that tomcat is. All we need to know is how to connect to that, and we connect to that via that DNS interface that console provides. I will be giving a talk about console in like a month, so most probably I can describe that more deeply on the second DevOps meetup here. So the drawback of console is that it doesn't listen on a standard DNS port. There's a custom one, so you just can't use localhost in your etcresult.conf file, as you can't specify the port there. You can specify just an IP. So we need DNS mask to actually relay all these DNS queries to console. So DNS mask listen actually on 53. So then there's a simple like the router procedure inside. So when we query console domain, then relay that to console. Otherwise, relay that to like Google DNS. So all we have to do is to change name server in etcresult.conf file, and the gotcha here is that when you like connect to any network, most probably you will get the DHCP server from your like DHCP server, DNS server from your DHCP server. So all the local changes in etcresult.conf will be overridden automatically. You can prevent those changes by overriding a single method in etc DHCP, enter hooks, whatever. You have to enter like 3 lines of code there, and your etcresult.conf file will never be changed. And that worked most of the time. And I'll tell you why it worked most of the time, not every single time in like 15 seconds. Alright, so that was the line. That was actually 3 lines of code, which is like super simple. And whenever you do like service network restart, you get that error. So we have like a single file, which is the file that was copied by Chef, and that file was like exactly like this at the very beginning of that snippet. So 3 lines of code, and that file was copied to the virtual machine by Chef. And you get that error that there's an issue at the very end of the first line, which is like kind of crazy. Where's the issue? This is how it looks. This is exactly the snippet of code you need to put in that file to prevent these changes. And what was the root cause of the problem? The root cause was actually that was the root cause. So, end-of-line characters. If you didn't change the way your Git client handles end-of-line characters, it basically means that on Windows, instead of \n, \r, \l, or whatever Windows uses, will be copied to that file, and when shell evaluates that file, it sees something different than with the Unix endpoint. So instead of \n, there's some different character, and that was the error. And we had like 10 similar issues, and it was kind of hard to track. But finally we found that. So you can enforce particular endpoint characters in your Git repository via the attributes file. Second thing is, we used to use Chef Solo for a very long time, then we switched to Chef Zero. And Chef Zero, for those of you who don't know, is like in-memory Chef server. So it starts pretty quickly. There is no like super security around that. The reason is to have like an exact copy, in-memory copy of the whole Chef server, which is like written in, basically it runs Chef server in like Postgres, Solar, Airline, Ruby, and a couple of other frameworks, which is kind of complicated. And here you have like a very simple single binary, which is written in Go. So that's really fast. So we switched to that almost immediately. But we switched back to Chef Solo pretty quickly. There's the bag. I filed the ticket like a week ago or 2 weeks ago, which is all about that whenever you run Chef Solo and have a lot of elements on your run list, it takes like additional 3 minutes every single time to basically Chef server is spending 3 additional minutes every single time you run that, doing completely nothing and printing a warning message over 400 times, which is kind of crazy, but this is how it looks. So we switch back to Chef Solo, and until that bug will be fixed, we are not going for Chef Zero anymore. So another like a tuning procedure we implemented was we reduced the amount of required plugins to the very minimum. In our case, that's just 1 plugin right now. So we used to use the Vagrant Virtual or Omnibus plugin, and those 2 plugins was all about Chef. Right now, there is a lot of functionality around Chef implemented directly in Vagrant, so you don't have to use these extra plugins. And if you don't use them, you can speed up the whole processing a lot. So if you can reduce them at plugin, do that. And also there's a lot of useful helpers in Vagrant. So things like require version, or if you have a plugin, or if the Vagrant version is something. There are some features of Vagrant 1.8 that was not available in 1.7, so you can specify like use this feature when Vagrant version is only greater than 1.8. Or you can use require version on the very top level of a file. So when the particular version of Vagrant is required, you don't have to worry about that. So whenever someone tries to run your Vagrant file on like 1.8 and you require 1.7, he will get an error immediately. So there is like instant feedback. And that's all I got. Do you have any questions?
No questions.
That's a surprise. I had like, all right.
About this DNS hooks?
Yeah.
Why you don't use simple environment variables to different between this locals and this other?
Yeah. So
simply on DNS.
The good thing about DNS is that you don't have to change your application at all. You're just using DNS, and instead of IPs with environment variables, you have to rewrite your application to use that. So that was like a kind of natural move.
Instead of using DNS hooks, do you consider using supersede in DHC file?
All right. So instead of like overriding or preventing changes in DNS resolve code, there is a way to supersede that in the HTTP server. That was the question, right? So it will, yeah. So it will require like a company-wide change, which is kind of risky on a production environment. So if you have like 200 developers, when you mess with DHCP, you can break a lot of things if you don't really 100% sure what you do. And that was like a much easier way for us to implement that just on Vagrant. For example, in AWS, we use a custom DHCP rule that enforces localhost as a first DNS. We can't do that like in a company network for various reasons. So that was the reason why we decided to go that route, went that route.
Yep.
Do you use any tests when you build backer boxes?
Up to some extent, that's true. So the question was, do we run tests against this Packer box or after Packer box is built? So that's kind of true to some extent. So we have another Vagrant box with all the test framework we use. We have like two internal tools for that. So if you'd like to verify what was built on that project Packer box, you can spin up another box alongside that and trigger a set of test suites from one Vagrant box against the other. But there's always a question: how do you test if the box that contains all the test tools? So we didn't test that, or actually we've never been thinking about testing that. It used to work for us, so there's always something has to be first. Basically, that's it. All right. Any more questions?
Because you mentioned that you are not using Docker. In our case, we dropped Vagrant 1 year ago for in exchange of Docker. And as my experience shows, there are also some problems with Vagrant that does not exist with Docker. Let's say, first of all, do you use the same operating system for all developers when you have this process? This is number one question.
Alright, so first question is, do we use the same operating system
But it's important.
for all the developers? Do you mean like on local machines?
Yeah, I mean on local machines.
Nope, we don't use the same operating system. So we have OS X users, Linux users, Windows users. So we need to have a VM on top of that, and we have to have a hypervisor that runs exactly on all these operating systems. So you don't have really other choice than VirtualBox these days.
Okay, so you are using VirtualBox, right?
Yeah, that's correct.
Okay, and how about Maven? Because you mentioned you are, if the developer want to do some change, are you mounting the Maven repository locally, or you are?
No. So the question was, how do we do deployments via Maven?
Yeah, I mean, because you can simply mount it directly from Maven cache, or you can do it internally inside the box. So that's the question.
Yeah. So the software we build is kind of specific. So we never like build software the way you probably think we do. So to build something in our case, we use a lot of Maven plugins, and all the deployment is via HTTP API. So when you do like Maven clean install, there's like a HTTP call to the service which is running in background, and we build code locally. So there's like a jar file and a zip file generated, and we upload that over HTTP. So we don't have to mount anything from the box, from the machine to Vagrant itself.
Okay, so basically you are building it locally, but you are pushing it back to Vagrant.
Right? Exactly.
Okay. Still it's slow, I think, but okay.
That's not really slow, actually. It feels like a native right now. So, Alright, so we're running out of time.
Yeah.
If you have any additional questions, I'll be around, so feel free to ask.